Alright, this is page 196, problem number 27, and I see it's an equation, a polynomial equation that I have to solve. I notice that I'm already set equal to 0, and although the left side is not in standard form, it appears to already be partially factored. So I'm going to break it down all the way to all of its factors. If you want to tell what the highest power of y would be if you multiplied this all together, you'd have a y squared times a y to the first times a y squared. So there would be, you would have a y to the fifth as your highest power of y, telling you that there's going to be 5 roots, 5 solutions to this equation. But since it is already factored, I'm going to understand first of all that y squared means y times y. So there's going to be 2 powers of y, or two linear factors there. And then I've got y minus 3, that's set because this is a linear y, y to the first power. And then this y squared minus 9 is a difference of 2 squares. So that breaks out to y plus 3 times y minus 3. And the whole thing equals 0. And then you see your 1, 2, 3, 4, 5 powers of y and your 5 linear factors of y. So now we know that I asked myself, what power of, or what value for y would make this y 0, therefore the whole equation true, and that's a 0. And the same thing for this one. And this solution, the y that would make this factor 0 would be a y of 3. And in this factor it would be a negative 3. And in this factor it would be a 3 again. So there's your 5 roots right there. And I like to list them from the leftmost on the number line, from the lowest value forward. So I have a negative 3, and then I have 0 that occurs twice, so that's a double root. And then I have a positive 3 that occurs twice, so that's a double root. And what this means is that if you were to graph, if this was x and you graph this polynomial on the xy plane, then you would have you'd have one place where it crosses the x-axis and 2 places where the graph just touches down on the x-axis. And that's it.